So this is going to be the last video I'll do on factoring for this week. I'll probably pick back up in a couple more weeks or so. So today I'm going to do another special case of factoring. We call this the difference or the sum of two cubes. All right, we're looking at a visual representation of a cube. All right, so the reason why we call these cubes are kind of simple. Say, for instance, this has a length of 3. This would also have the same length of 3. And then when you look at how tall it is, it also has a length of 3. That's why if we're talking about a cube, we're talking about something raised to the third power. You get what I'm saying? So let me put some units on here. So what we're looking at is 3 times 3 times 3, which is 27. But then we're looking at inches times inches times inches. And now that's inches cubed. That's why we say third power is cubed, because if we were to turn it into a 3D object, it would be the shape of a cube. All right, the key to getting this type of factoring is recognition. You got to be able to recognize numbers. If I give you a number like this, 27, in the back of your mind, you should also be thinking, okay, that's also can be written as 3 to the third power. Same thing with 64. 64 can be written as 4 to the third power. 64 is a special case because it can also be written as a square. So that happens sometimes, but you want to make sure that you're paying attention to your list of cubes. So the more you create these lists of numbers, the less you have to think about it later on when these numbers pop up. Like when I see 1,000, I'm automatically thinking 10 to the third power, because it's going to be this that's going to help me factor when it's time to. All right, so that's enough with like the foundational part of it. This is where the algebra comes in at. This is the part that the pattern that we have to learn. All right, so a sum of cubes, basically, you have two things that are raised to the third power with an addition sign in the middle. Or the difference of cubes, you have two things that are cubes with a minus in the middle. If either one of these happen, they can be factored using this pattern here. All right, the way that I started to pay attention to it is, once you know what this is, the A and the B happen to be the roots, all right? The roots would actually go into the first set of parentheses. So whatever these roots are, that's what you start off with. Whatever that sign is, that's what you start off with. So if we're dealing with an addition of cubes, then you're going to have the root with addition in it. If you have a difference of cubes, you're going to have the roots with a minus in the middle. To prevent confusion on the second set of parentheses, all you have to do is pay attention to the first set of parentheses. Just know this one is being raised to the second power on the front. This is being raised to the second power on the end. Focus on the middle. Multiply these together and change the sign. That's pretty much the way that I was able to remember it. See that? I have an AB and I changed the sign to a minus. Look at that. That's to the second power. That's to the second power. I put these together and change the sign, and there they go there. If you follow that one every single time, it can become routine when it's time to factor. So I'm about to get to some factoring examples now. So here's our first example. I have 125x cubed plus 8. 125x cubed plus 8. The main thing here is to remember you have to be able to recognize your numbers. When I see a 125, I'm thinking, okay, that should be like a 5 and an X. See that? And what's happening is that's being raised to the third power. The 5 and the X is being raised to the third power. When I see that 8, I know that's a 2 being raised to the third power. So it's these parentheses that's going to help me get into those parentheses. So we present you a problem one way, but you have to know what's going on behind the scenes to see what's in these parentheses. Those are your roots that we have to start transferring. All right, so the 5x plus 2 is what goes directly over here. Now remember, all we're going to start doing is we're going to raise things to the second power first and put those on the ends, and then we're going to take care of the middle last. All right, so 5x times 5x. Remember, 5x times itself, that's the second power. That's 25x to the second power. 25x to the second power. and that's what goes there. 2 to the second power is a 4. So now I got a 4 there. The only thing that's left is the middle term. And remember, we multiply and change signs. So we say we multiply and get 10x. We change signs and get a negative 10x. So the minus 10x is in the middle. And that's what we have. 5x plus 2 times 25x squared minus 10x plus 4. All right, so that was my first example on a sum of 2 cubes. The next example will be like a difference of 2 cubes, and I think that'll be it, because that's the only thing we have to learn today. Is just it's a small pattern. You recognize the roots, and from there you can raise to the second power. You multiply and change signs. There's really nothing else to it.